So நம்ம வந்து last classல I have shown you the animation video for the chapter system of particles. நம்ம அதெல்லாம் பார்த்துட்டோம், system of particles and rotational motion. So we have seen animation videos, simulations பார்த்துருக்கோம். So now we are moving on further. Now I'll give you some important formulas. There are so many formulas in this chapter, and we will look at all the aspects of the formulas, the important concepts, and then we will touch the problems. Slowly we will start touching the problems. That is what I have planned for the day. So what I will do, just give me a minute. I'm getting things ready. I'm just downloading the formula sheet itself. I have kept formula sheets which are ready with me. So I'm just downloading it from the drive. Okay, so meanwhile I will start sharing. Just give me a minute. Getting things ready.
Good evening, sir.
Yeah, good evening. Yes. In case you wanted to ask something, you can ask me. Okay. So background, I'm downloading it. So physics, it's not at all a difficult subject. It's if you love physics, you will definitely you can score well. அந்த அளவுக்கு ஒரு டஃப்பான சப்ஜெக்டே கிடையாது. நம்ம பார்க்குற விதம் தான். நமக்கு டஃப் அப்படின்னு நமக்கு பட்டுச்சுன்னா எல்லாமே டஃப்பாக தான் இருக்கும். If you feel it is easy, it is going to be easy for you. That's it. So it all depends on how you look at the subject. அவ்வளோதான். நம்மளோட பாயிண்ட் ஆஃப் வியூ தான், நம்ம பெர்ஸ்பெக்டிவ் தான். இட்ஸ் பியூர்லி யுவர் பெர்செப்ஷன். பட் பேசிக்ஸ் கொஞ்சம் நீங்கள் நல்லா ஸ்ட்ராங்காக இருந்தீங்க அப்படின்னா, ஸோ யூ கேன் டெஃபினெட்லி அப்ரோச் கொஷின்ஸ் இன்னும் கொஞ்சம் நல்லா அப்ரோச் பண்ணலாம். யூ நீட் நாட் பி ஸ்கேர்ட் அபவுட் தி டைப் ஆஃப் கொஷின்ஸ், ப்ரொவைடட் யுவர் ஃபவுண்டேஷன் அண்ட் பேசிக்ஸ் ஆர் வெரி ஸ்ட்ராங் அண்ட் கிளியர். யூ நீட் நாட் வரி. சரிங்களா?
சந்தோஷ், எதை கேட்க வந்தீங்க?
யா, யூ வாண்டட் டு சே சம்திங், யூ கேன் ஆஸ்க்.
நோ சார்.
ஓகே. யூசுவலா அந்த பிசிக்ஸ் எப்படின்னா, முதல்ல நம்ம சயின்ஸ்ல ஆரம்பிப்போம் ஸ்கூல்ல. அப்புறம் கொஞ்ச நாள் கழிச்சு அதுல ஒரு பிரான்ச் பிசிக்ஸ் இன்ட்ரெஸ்ட் வரும். அதுக்கு அடுத்த பிசிக்ஸ்க்கு அப்புறம் உங்களுக்கு வர்றது எலக்ட்ரானிக்ஸ் வரும், எலக்ட்ரிக்கல் ஆர் எலக்ட்ரானிக்ஸ் ரிலேட்டடா வரும். அதுக்கப்புறம் யூ வில் கோ ஃபார் மைக்ரோ ப்ராசஸர். அதுக்கப்புறம் யூ வில் கோ ஃபார் மல்டி ப்ராசஸர். அந்த மாதிரி எப்படியே போகும். ஸோ தட் இஸ் அ ரூட். எலக்ட்ரானிக்ஸ் அண்ட் பிசிக்ஸ் கனெக்ஷன் அந்த ரூட் அண்ட் பேர் அதுக்கு. அதே மாதிரி எலக்ட்ரிக்கல்லி அதே மாதிரி தான். பிசிக்ஸோட பேஸ் வேணும், தென் யூ வில் கோ இன் டு எலக்ட்ரிக்கல் சைட். மெக்கானிக்கல் அது ஆல்சோ அந்த மாதிரி போவீங்க இன்ஜினியரிங் பொறுத்தவரை. Paul Simon, ஏதாவது டவுட் இருக்கா? I mean, you want to ask any general doubt about the subject or anything, you can ask, because till that time our teacher downloads from the drive.
Sir.
Okay, sir.
Sir, one doubt, sir.
Yes.
Sir, physics எப்படி சார் ஸ்டார்ட் பண்றது? ப்ராப்ளம்ஸோட ஸ்டார்ட் பண்றதுங்களா இல்ல லெசன்ஸ்லாம் முடிச்சிட்டு ப்ராப்ளம்ஸ் போறதா சார்?
ஒவ்வொரு கான்செப்ட் முடிச்சுட்டு ப்ராப்ளம் போறது ஐ வுட் டெஃபினெட்லி ரெக்கமெண்ட். ஏன்னா ஒரு கான்செப்ட் நீங்க படிக்கிறீங்க, நல்லா அது புரிஞ்சிருச்சு உங்களுக்கு, இம்மீடியட்டா அது பேஸ்ட் ப்ராப்ளம்ஸ் நீங்க பார்க்கணும். ஒரு 3-4 டைப்ஸ் ஆகுது. தட் இஸ் வாட் ஐ வுட் ரெக்கமெண்ட். ஸோ அப்படி பார்த்துட்டீங்கன்னா உங்களுக்கு சைட் பை சைடு அந்த கான்செப்ட் கிளியர் ஆயிடும். பிளஸ் பேஸ்ட் ஆன் தட் கான்செப்ட் நியூமரிக்கல்ஸ் ஆர் ஆல்சோ யூ ஆர் கிளியர். That is the best approach, I would say.
Sir,
yeah.
Chemistry எப்படி சார் படிக்கிறது? ஆர்கானிக் வொர்க் அவுட் பண்ணி பார்க்கறோம் சார். பிசிக்கல் அப்புறம் இன்ஆர்கானிக்லாம் எப்படி சார் படிக்கிறது?
Physical, so அதுக்கு ஃபர்ஸ்ட் நீங்க தியரி, that is based on the type of chapters. So சில சாப்டர்ஸ் ஃபுல்லா தியரி பேஸ்ட் இருக்கும், சில சாப்டர்ஸ்ல நமக்கு நியூமரிக்கல்ஸ் இருக்கும். If you look at electrochemistry பார்த்தீங்கன்னா, you have இந்த Nernst equations, அதுக்கப்புறம் உங்களுக்கு இந்த ஹென்ரி ரால்ஸ் லா இதெல்லாம் யூஸ் பண்ணி இது சொல்யூஷன்ஸ் சாப்டர்ல கூட நியூமரிக்கல்ஸ் வரக்கூடிய பிளேசஸ் இருக்கும். ஸோ யூ வில் ஹேவ் டு ஃபர்ஸ்ட் கோ த்ரூ த தியரி பார்ட் அண்ட் அதோட கான்செப்ட்ஸ் கிளியராக பார்த்துட்டீங்க அப்படின்னா தென் யூ கேன் ஸ்டார்ட் ஒர்க்கிங் ஆன் தி டைப் ஆஃப் கொஷின்ஸ். இப்போ கொஷின்ஸ்க்கு உங்களுக்கு தியரி பேஸ்ட் கொஷின்ஸும் வரலாம், நியூமரிக்கல் பேஸ்ட் கொஷின்ஸும் வரலாம். ஸோ இன்ஆர்கானிக் பார்ட் பொறுத்த வரைக்கும், so உங்களுக்கு the type of the number of questions which are based on theory would be greater than numericals. So theory questions அதிகமா வரக்கூடிய chances chemistryல எப்பவுமே இருக்கு. And plus equations related questions, ஏன்னா organic plays a major role அப்படிங்கிறதுனால you will have questions from organic part also, plus theory part from inorganic and few numericals. Not to avoid, but numericals also they will ask. So concepts first படிச்சுக்கோங்க. அது அண்ட் உங்களுக்கு அந்த ஒவ்வொரு ஃபார்முலாவும் பேஸ்ட் ஆன் த சாப்டர்ஸ் இருக்கும். ஸோ லேர்ன் தி ஃபார்முலாஸ், ஈச் அண்ட் எவ்ரி குவான்டிட்டி யூ லேர்ன், தென் யூ ஸ்டார்ட் சால்விங் ப்ராப்ளம்ஸ் பேஸ்ட் ஆன் தோஸ் கான்செப்ட். சேம் லைக் ஃபிசிக்ஸ் ஒன்லி, இட் கோஸ் ஹேண்ட் இன் ஹேண்ட். Oh, provided the concepts are clear, you can start approaching. So I would say for chemistry, first theory full முடிச்சிருங்க அந்த chapter. முடிச்சிட்டு அதுக்கப்புறம் நியூமரிக்கல்ஸ் தொடுறது would be better for chemistry. Physics வந்து ஒவ்வொரு டாபிக்குமே you can start working on numericals. Not necessarily ஒரு chapter full-ஆ you need to study and then go with numericals. அப்படி பண்ண தேவையில்லை. So I hope you're getting it.
Sir, another doubt, sir.
Yeah.
Sir, ஃபாஸ்டா நம்மளுடைய போர்ஷன்ஸ் எப்படி சார் கம்ப்ளீட் பண்ண முடியும்?
ஃபாஸ்டா போர்ஷன்ஸ்னா இந்த you're asking about crash course?
Yes, sir.
ஓகே, கிராஷ் கோர்ஸ்னா இப்போ 3 மாசம் இருக்கு எக்ஸாமுக்கு, எப்படி நான் முடிக்கிறது, ஹவ் am I going to study, what is the strategy அப்படின்னு கேட்குறீங்களா?
எஸ் சார்.
ஸோ இப்போ நமக்கு டைம் குறைவா இருக்குன்னா you should never go through each and every chapter completely 100%. It's not possible. So I would recommend you to first learn formulas chapter wise. If you're studying for last minute preparation, formulas, all chapters formulas, theory, important concepts பார்த்துட்டு you must sit with previous year questions. Previous year, at least last 5 years question papers you will have to solve. ஒவ்வொரு last 5 years papers எடுத்துட்டு நீங்க அதுல வந்து பாருங்க from which area the questions are repeating more, or எந்த ஏரியால இருந்து நிறைய questions வரக்கூடிய ஒரு சான்ஸ் இருக்கு அப்படிங்கறது பாருங்க. So mostly organicல இருந்து எந்த chapters நிறைய weightage இருக்கும் and which chapters are less, and you can have a clear idea. So I would recommend all questions you do, irrespective of weightage, you learn all the questions in the previous year question papers of NEET for at least 5 years, இல்லனா at least 4 years படிச்சீங்கன்னா அதுவே போதுமானது. That is for last minute preparation strategy. So there, while doing problems, உங்களுக்கு அந்த concepts also you can learn the formulas also, and main thing வந்து ஒரு book maintain பண்ணிக்கோங்க. So அந்த problems நீங்க solve பண்ணும்போது and that you have to just make a note of the chapter name and write down the formulas also for that, so that உங்களுக்கு அதெல்லாமே cover ஆயிடும். So that way you can definitely go ahead for last minute preparation or crash course kind of a preparation. Okay.
Okay, sir.
Sir,
Yes, சொல்லுங்க.
It's not related to this the chapters or what we are dealing with. The other day, I don't know. I have an idea, sir. I had an idea. I don't know if it's practical. I just wrote it down. So my dad told me to ask somebody who is good in physics. There is a magnetic field and there is a coil of wire. The wire is rotated and the magnetic field will be cut through. And they say that this will produce a alternating current.
Yes.
So this current, it can be used to run a motor connected to a fan of some sort. And
Yes.
if we connect the fan to the coil of wire, and if I somehow give it a jump and the wire keeps rotating, will it produce electricity to run the motor, sir? Like it's like a
From the motor, in the sense, if it is going to be a turbine kind of a setup where you have mechanical energy being converted to electrical energy, yes, of course you can generate, but you will also have to look into the efficiency part, whether completely, whether it's going to be 100% efficient. In reality, none of the generators are 100% efficient. There is a loss of energy in the form of heat, thermal friction, etc., etc. So therefore, maybe you might be 70 or 75% efficient motors, generators are available, so that much you can convert and you can use, wherein the other 25% or 30% might be wasted as heat or frictional thermal loss, like that.
Yes, sir.
Yeah.
Thank
Correct.
you.
So that we'll be learning when we'll be touching alternating current, which comes in grade 12 topics. So you will we'll be having a clear view about that. Okay.
Yes, sir.
Yeah, welcome. Yeah, it's downloaded. I'll just start sharing it. Just let me know, if you're able to see it. Now, what I'm doing is, instead of, starting with again a new chapter, whatever we have done so far, we look at, different types of questions. We will also run through the concepts. So I feel that is quite important. Because, as we are covering, of course we are covering, there is no doubt about it. I just want to ensure that, you guys are in track. Okay, so today we'll have a quick recap of everything what we have learned so far, all the concepts, and we'll look at different types of questions also, okay, from the competitive point of view. So that is what I've planned for today. So yeah, it's going to share now. Just let me know if you're able to see it. Yes, so children, I hope it's visible to you guys now. I've started sharing the screen. So just let me know if you're able to see it. Okay, so these are specialized notes which I'm having. So I'll share these notes also with you. Okay, once I've done with it. Okay, so we'll have a quick run through of what we have learned so far. Okay, starting from the first chapter. So the first 5 to 6 chapters consolidated is what I'm having, the material. So we'll go through it. So starting with the system of units, I hope you guys are very clear with the different types of system of units that we have learned. We have two prominent units, which is CGS system, FPS system, and one more also, 3 we have MKS system, right? So CGS system, we have centimeter, gram, and second system. Okay, so centimeter is the unit of, can anybody just have a quick recap? It's a unit of
length.
Length, very good. And gram is a unit of
mass.
Mass, yes. And second, as you guys know, it's a unit of time. So that is, M, L, and T would come up in dimensions. We have learned dimension formulas also in detail. Okay, so centimeter, gram, second is a smaller version of MKS, wherein you have the smaller units of length, mass, and time which is being used. Same way we have FPS system, which is also known as the British system of units. It's foot, pound, and second system, where again foot would represent the unit of length, pound represents the unit of mass, and second is same as for time. And then we have MKS system. With this is a bigger version of CGS, wherein you have meter. Unlike there we had centimeters, here you are having meters, which is again for length. Then you have for mass, it is in kilograms here. Time remains same for all the 3, which is seconds. Okay, yeah, so this is all about it. And then we have also learned the 7 base units, fundamental base units. Can anybody recapitulate the 7 base units that we have learned? What are the 7 base units? Yeah, first we'll go one by one. What are the 7 base units? First one is the unit of mass, right, which is kilograms. Then we have the unit of length, meters. Then unit of time, seconds. Then what do you have? We also have, correct, the unit of luminous intensity, which is candela. Okay,
sir,
yeah,
temperature, sir.
Yes, you have the unit of temperature, which is Kelvin. That's correct. Then the amount of substance, which is moles.
1 mole, sir.
Correct, mole. Okay, and then appropriately we also have plane angle, and we also have something called as solid angle. These are 2 supplementary units along with them. Okay, so one is plane angle and one more is solid angle. Plane angle, you can see a simple example for a plane angle would be a piece of you just cut out a pizza, so you can see the angle is nothing but a plane angle. Same thing if you're going to cut out from a cake. You imagine there is a big width. Pizza, we will neglect the thickness. The thickness is very, very small, you imagine. Okay, in that case it is going to be a plane angle. Suppose you have thickness, considerable thickness, in that case it would be a solid angle. A piece of cake can be a classic example for a solid angle, where it creates an angle in between. Okay, so here you can see there is a radius r, and you also have the arc which is being subtended, which is given as S. Okay, So this is basically the figure for that. So we'll move on. You can see the relation is the angle is nothing but the arc subtended upon radius. Okay. Now this does not have any particular dimension. We just say the unit as radians. That's it. Okay. So we'll move on. And this is how you represent for the figure is for solid angle. You can see. So change in area upon square of the radius. Okay. Now again coming back to dimensions, we have already learned the dimensions. For density, you can see mass per unit volume. Mass, you represent dimension as m. For volume, you know that there is length, breadth, and height that is involved. All of them belong to length itself. So length cubed. So mass upon length cubed. Simplify it and represent in numerator. You get ml to the power minus 3. Okay. Or you write it as fundamental. You write them and the standard dimensional formula. You will write it as m l power minus 3 t power 0. Obviously there is no time, but still we represent it as t power 0. Okay, you show m, l, t, all three letters, mass, length, and time. Of course there is no time involved in density, but so you just incorporate the exponential value as 0. Okay, so all this we have learned, we have seen. And you can see they have also mentioned the constants such as pi or 1 by 2 trigonometric functions like sine theta, and sine, cosine, etc. They all have no units and there is no dimensions involved with them. Okay. Yeah, and here you can see all the physical quantities they are given. Different physical quantities, what are their formulas, appropriately dimensions and their SI units. For area, you can see dimensions is just L square and the unit is meter squared. For volume, it's meter cube, so it will be L cube. For density, just now we saw L power minus m L power minus 3, okay, kilogram per meter cube or grams per centimeter cube. Okay, they have given in SI units. So what would be in the appropriate CGS units? That also you will have to know. So for density, if it is kilograms per meter cube, equivalent in CGS units would be grams per centimeter cube. Okay, so that's also very important. Velocity, the SI unit is in meters per second. Okay, now the CGS unit would be in centimeters per second. All right, so that is the transition. So you will have to know that. Acceleration against velocity upon time or change in velocity upon time. So again meters per second square, or you can change it to CGS version as centimeter per second square. Okay, force is represented in newtons, the product of mass and acceleration. So you can write it as kilograms meters per second square. Okay, same way for pressure, you can see the unit SI unit is Pascal. For work, the SI unit is joule. You can see work, potential energy, kinetic energy. Okay, generally all energies, they have the standard unit as joule. Okay, so it is same for them. And for power, you can see the unit is watt. The SI unit is watt or it is watt. You pronounce it appropriately. So it's work done upon time or the rate of doing work. Okay, dimension formula is also given. This is quite simple. You guys know the formula. Momentum, product of mass and velocity. Appropriately, you can write its dimensions, and the SI unit is kilograms meters per second. For angle, just now we saw it is arc upon radius, dimensionless. You can see all the powers are 0. Same way for angular velocity, change in angle upon time, it's radians per second. There is dimension here. You can't say for angular velocity dimension is 0 because it's radians per second. And for impulse, the product of force and time. Okay, when force acts on a body for a particular time duration, there is impulse in it. So the unit is Newton second because force has got the unit Newton, time has got the unit second. You combine both, you get Newton second. Then we have moment of inertia, which is the product of mass times the square of distance. Okay, from that corresponding mass, which is kilograms meter square. And torque is the product of force multiplied by distance, the perpendicular distance from the line of action. So it is Newton meter. And you can see torque and impulse, they have the same, they have different, units. Sometimes, people tend to confuse. There it was Newton second, here it is Newton meter. Both are different. And angular momentum, you can see it's product of mass, velocity, and distance. So kilogram meter square per second. Same way for stress. Stress is again defined as force per unit area, which is Newton per meter square. So that is for stress. And again for strain, you can see change in dimension per original dimension. That is the formula for strain. It can be change in length per original length, or it can be change in volume per original volume, or it can also be change in area per original area. Okay, so there is no unit because length, volume, and area get cancelled off. That's the reason it is dimensionless. Okay, and does not have unit. Modulus of elasticity is the ratio of stresses to strain. Okay, so we have different types of modulus of elasticity. We have Young's modulus, bulk modulus, rigidity modulus, etc. Now again, you can see we know that stress does not have any. Stress has particular unit because it is force by area. It was Newton per meter square, but strain did not have any area, so the did not have any unit. So modulus of elasticity will have unit. Yes, of course. So the unit is Newton per meter square. Okay, so we can express it like that. Surface tension, the amount of force acting per unit length. So that is again Newton per meter. Okay, so then you have Planck's constant. This would you frequently come across in chemistry. It is energy upon frequency. I hope you guys would have learned the equation E is equal to h nu. Okay, where E is energy, h is Planck's constant, nu is nothing but the frequency. You go for a rearrangement, you get h is equal to E upon nu. So E is energy, which is joules, and frequency is nothing but the reciprocal of time period. I hope you guys know that. F is nothing but 1 upon t. T is in seconds. That seconds would come up. That's the reason they write it as joule second. So Planck's constant has got the unit joule second. Okay. Electric charge. You know that the rate of flows of charges is basically electric current. So go for a rearrangement. You can write Q is equal to I into T, which is current into time. We know that current comes in the fundamental base unit as ampere, and time has got the unit second. So it's ampere second. Okay, or you can also represent it as coulombs. Okay, ampere into second is nothing but coulomb. Fine. So like this, you should know the relation. So here all the formulas are represented. So these 30 formulas are very, very important. Different types of questions can be asked based on the methods of dimensions. That point of view, this is important. Potential difference is again the power upon the ratio of power times electric current. So which is again volt. Okay, from Ohm's law, you know that volt V can be written as the product of I into R, which is current into resistance. Then you have resistance. Again, go for a rearrangement. You can represent resistance as the letter R. The unit is ohms. Okay, same way electric dipole moment, product of charge and distance, which is coulomb meter. Charge is coulombs and distance is in meters. Electric field, the ratio of force upon electric charge, which is wherein force is newtons and charge is in coulomb. That's why it's newtons per coulomb. All right. Then we have, last but not the least, we have magnetic field, which is the ratio of force upon current times length. Okay, the expression for this is Tesla. Okay, so these are certain important formulas for which the dimensions and the SI units are quite important. Okay, that's why we had a quick run through of all these dimensional formulas. Okay, now you can see here there are different rules that are quite important whenever you want to check the consistency of equations, whether they're dimensionally correct or dimensionally incorrect. Second, you would like to find out the relation between fundamental units by using the method of dimensions. That is also quite possible. So there are certain rules and regulations that you will have to follow. You can see the first one is addition and subtraction between two quantities. They are possible only if they have a similar unit or the same dimensions. For example, you can add relative velocity with velocity. That's possible. Why? Because both of them have the same unit meters per second. That's possible. But what if I want to add two quantities, same physical quantities, but with different units? Is it possible? I am having a velocity, say VA is 6 kilometers per hour, but I'm having VB as 3 meters per second. Can I add them directly? Would it be right?
Sir.
No. So either you convert kilometers per hour to meters per second, or vice versa before you go for addition. That's quite important. Even though physical quantities are same, but still you ensure that both of them are in MKS or both of them are in CGS units. That's very important for us. Only then you can perform arithmetic operations such as multiplication, addition or subtraction. So that's something that you will have to remember. Okay, in case of trigonometric functions, again you ensure that you add trigonometric functions of the same kind. For example, if it is going to be sine, you can add sine with sine, but not with cos. Okay, so either if you want to add sine with cos, convert cos in terms of sine or sine in terms of cos before doing so. Same would apply also with logarithmic functions, okay, and exponential functions. Either if you have exponents, convert exponents in terms of log to the base 10 or log values in terms of exponents before you go for subtraction or addition. Fine. So and then you have so here you can see they've given you an expression. Now the question is, what are the dimensions of A, B, C, and D? There is a simple question here where they've given V is equal to AT plus BT squared plus C, okay, plus C, and you have D upon T plus D. So they've just given you an expression where V is velocity, T is time, A, B, C, and D are constants. Okay. Now here there are two plus signs. Just neglect one of them. One is extra, so I'll just strike it off. Okay, this one is extra. This is extra. I'm just striking it off. Okay, we just have one plus sign there. Fine. Yeah. So now the question is, what are the dimensions of A, B, C, and D? That is the question. Now again, look at A. They already told you that V is velocity. Okay. Now you can see here D must have the dimensions of time they are saying. Okay. Now we try to express them in terms of their in terms of the general dimensional formulas which we know, where we use M, L, T, and so on and so forth. Okay, so you represent them. You know that velocity can be expressed as displacement or distance upon time. So when you go for doing that, you can see that the time component would get cancelled off, and you can express all of them in terms of their corresponding constants, either A, B, C, or D. So we can express them. So by simple method of comparison, you can express them. D would be expressed in terms of time. Then you can see V is nothing but can be expressed in terms of A into A and T by comparison. So like this, you can go and express. This is just a sample question. So yeah, just for our understanding. Now again, here also you can see that they've given you a question where U is potential energy. They say X is distance, T is time, and they're relating U as bx squared upon T squared plus C. Okay, you need to find the dimensions of B and C in this case. So here you try to find out what are the dimensions of B and C. Now here again, you know that you try to find out on both the sides. Either you can start with LHS or with RHS. The choice is yours. So try to isolate one of the terms, and then you try to find out the dimensions. So if you want to find it out for B, keep B on one side and shift all of the terms for the other side, and then you go for a simplification. So that is what we typically do. Okay, so you try to find out like that. So here you can see when you want to find out the dimensions for B and for C, go for a rearrangement. They are telling you is potential energy. Now you guys know that potential energy means what? Energy has got a particular dimension, right? The dimensional formula for energy as such, you people know that it is ml square t power minus 2, right? Unit is the fundamental SI unit is joules. So it is ml square t power minus 2. You can see that is what is used. B is a constant, x square, x is distance, so L square, B times L square upon T square, because time, plus C. C is a constant. Constants won't have dimensions. Okay, but here they are telling, here you try to express them. You want to find it out for C, so keep it on one side and then go for a shifting. Okay, so one by one you would approach. First find out for B, then you will go and find out for C. So like that. Yes.
Can you please show me the answer for the question before this one?
Yes, I'll show you. It's here.
Thank you, sir.
Okay, these are the values. If you want to just take a screenshot. Okay. Yeah. Done?
1 second, sir.
Yeah.
Yes, sir.
Done? Okay. Fine. So I hope that part is clear. The second part. So you on both the LHS, you express the dimensions and then go for a compare and contrast model. X is distance, distance squared. That's the reason they have put L squared. And in the denominator you have T squared plus C. You can see T is nothing but time. That's the reason capital T squared is put in the denominator. And then you go for a rearrangement, go for a simplification. You will get B is equal to M. So the dimensions of B is M. It is mass. Okay. The dimensions of C is T squared. Okay, so like this you can easily find them out. Fine. So this is what is for the second question. All right. I hope the second one is clear. We'll go to the third one. Now these are different models of questions, how it can be modeled, wherein they can introduce different constants of their choice, and they can ask you what are the dimensions of one of the variables that are introduced in the expression. So questions can come like this also. Okay, so this is one way of asking. You have one more question also. Here you can see the question is in terms of a mathematical expression. They have given you trigonometric based questions. Okay, wherein they have given you x is equal to a times sine bt. Now, very important to note, b and t are angles together. Okay, you don't see a t as separate and b as a separate expression. Together they are angles. You would only look at bt as an angle, something like theta, where here theta is nothing but bt. I hope you guys know how you express trigonometric functions. We say sine theta, isn't it? Same way, instead of writing theta, here they have written b into t. bt is nothing but theta here. Same way, cos dx. dx is again theta. It's an angle. That's the reason they have put it within a single common bracket. So x is equal to a sine bt plus c cos dx. Okay. Now here, the assumption is if x is distance and t is time, they're asking you to find out the dimensions of a, b, c, and d. Okay, now that's what they're asking. If x is distance, obviously we know the unit for distance is going to be L. That is known to us. All right. Now here you go and express. You try to find out. Now what about bt and what about dx? So we try to find out here. Okay. Now you try to find out for b, but what about t? T is nothing but time. Okay, so time term is coming into picture there. Okay, now what about a term? X is equal to a sine bt. When you say now x would represent what? It is representing distance. So here this function is representing a distance for us. So a is nothing but the amplitude of the function. So the amplitude means it is the peak distance or the peak amplitude we say. So again it is length only. Okay, so it's a function, it's a displacement function. So a represents the amplitude of that function, which is also a distance. So you can directly say the unit of a is nothing but length, L. So a is length. Okay, now bt, sine bt, obviously bt totally itself is going to be theta, and you know that theta is dimensionless. Okay, same way dx, theta is again going to be in radians, again it is dimensionless. C is equal to length. So that way you can find out the dimensions of each and every quantity in particular. So like that you can find out. So this is how you can correspondingly find out the dimensions of each and every letter that is given in this particular function here in this case. Okay, so that's how you represent. Now, how is b t to the power minus 1? The reason here, being because it has to be dimensionless. Now, don't you think to make it dimensionless, you will have to divide it by time, because you have b into t. T is obviously having dimension because it is time, right? But bt as a whole belongs to a theta, and theta is dimensionless. So therefore, to make bt completely dimensionless, you divide it by time. That's the reason b has got a dimension of t power minus 1 and d has got the dimension L power minus 1 because it is clubbed with length x. Okay, so this is how you apply your logic, and you try to find out what are the dimensions of the expression. Okay, I hope this part is clear. Okay, that's the reason I stopped by and I explained this part. Is it clear to all of you, this question, this trigonometric based question?
Yes, sir.
Okay, great. So we'll move on to the next one. Again, you have a question, logarithmic based question, wherein x is equal to a log bt squared upon c plus a. Note that the complete function for the logarithm is represented using the square bracket or the square parenthesis, wherein x represents distance and t is representing time. They are asking you to find out the dimensions of a, b, and c. Okay, so that is what we are supposed to find out. So how do you do that? You can see the dimensions of c, you try to find out. Now again, you try to express them, this corresponding function. Look at the terms which are present next to them. So for b, it is clubbed with t squared. Okay, so now you go for expressing b as a function. So how do you express that corresponding function? Now you know that whenever you have a logarithmic function, the entire function is going to have a particular value. That value can be an integral value, or it can also be a decimal value. When I talk about an integer or when I talk about a decimal, I'm only talking about a number. I'm not referring to that particular, that number has no meaning until and unless I'm saying 5 meters or I'm saying 5 kilograms. I'm only saying 5 or I'm saying only 5.2. Means it's just a number. Okay, it's not accompanied by any unit. It is only a numerical value that I'm talking about. So when you have only a numerical value, that means, does it have any dimension? No, absolutely it will not have any dimension. So therefore the entire term within the logarithm would not have any dimension in this case. So therefore, what would be the dimension of b? By just looking at the expression, you can say what is its dimension. How do I say it? Because it is clubbed with t square. I know t square has dimension t to the power 2. So to make b t square itself dimension, what would be the dimension for b? It would be t power minus 2. Now if I substitute t power minus 2 to b, don't you think the term would become dimensionless? Yes, it would, because t power 2 times t power minus 2 would become t power 0, which making it dimensionless, and that would make sense. Okay, so like that you would substitute, right? Same way again for the denominator terms. You have c plus a. So again, c plus a you would find out. So one of them, so they are saying you try to find out what is the corresponding dimensions for c and a. So again, what would you do? It is, again, if we talk about the length. Okay, so length in the sense, because the entire function is represented in terms of length. Why I'm saying a is length? Because I'm expressing x as a function of distance. X is equal to a log something. That means you have a is nothing but would be the amplitude of that corresponding function. So amplitude of this function would also be displacement, which is a unit of length. So if a is length, then c, what would be the dimension of c? It would be L power, is it L power 1 or it is L power minus 1? So appropriately it has to be dimensionless. You make it dimensionless in the process. Okay, so like that you would find out. Okay, so they have written it as L, and c is also going to be expressed as length, and you have an a on the top also, and they would get cancelled off, leaving behind L. Okay, so that is how you would express that. Simple. Okay, so that's how you find out what are the units, what are the dimensions of each and every variable in the expression. Same way again, they have given you f is equal to at plus bt squared. Again, for this also I think you guys can express it. You can find out what are the dimensions of each and every constant, or the variable which is present in the expression. Wherein f is force, t is time, they're asking you the dimensions of a and b. I hope you guys can do this, right? Because it is a function of force. So force has got the dimensions ml t power minus 2. You go and find out what are the dimensions of each and every expression by comparison. Okay, and you can find out what is a and you can find out what is b. All right, so this is quite simple. So like this, you have different expressions where you can find out the dimensions of each and every variable. And going on to the next part, we have also looked at what are the applications of dimensions. You can find out whether both these sides are same, the LHS and RHS. You can find out the inconsistency of the formulas or the equations in physics. Okay, so that is one application. So they'll give you an expression like this. This is a time period of a simple pendulum where t is equal to 2 pi under root of L upon g. And they ask you whether it is dimensionally correct or not. So what do? The LHS side is t. T has got time. T is nothing but time. The dimension of time is t, capital T. Done. What about 2 pi? Would 2 pi have any dimension involved with it? 2 pi is nothing but a constant, isn't it? So it is dimensionless quantity. Now the expression with under the root, you will have to be concerned about that, because it is a ratio of length and acceleration due to gravity. You know that length has got the dimension L, acceleration due to gravity has got the dimensions, it is meters per second square. So L t power minus 2. On the top you have L, and the bottom you have L t power minus 2. Correct? So you take it up, you can see that L would get cancelled off and t power 2 would remain. So under root of t power 2, so square can be taken out and you would ultimately get t. So therefore LHS is equal to RHS, and this expression is dimensionally correct. Okay, so you can prove the consistency, or you can check the consistency, the dimension, dimensional correctness of expressions and equations, provided you're able to establish a relationship that the dimension on the left hand side is equal to the dimension on the right hand side. If both are same, you say that expression is dimensionally correct, and if they are not, you say the expression is dimensionally incorrect. Okay, that's quite I hope this part is clear. Okay, how to check the expressions for the dimensional correctness. Okay, so moving on, same you would do here also, where h is equal to 2s cos upon drg. So usually it is cos theta or something, delta, so it is not expressed because anyways that's going to be a constant term. Okay, so d, r and g, where d is density, r is radius, and g is gravitational acceleration due to gravity. Okay, again you express the terms and you prove whether it is dimensionally correct or not. Okay, this is also the same approach as we have done for the previous one. Okay, so moving on to the next one, and the importance of numerical values and the physical quantities associated with them. Okay, so here next we will try to convert from one system of units to another for this given same physical quantity. Meaning you try to convert a particular physical a physical quantity in one system of unit to another system of unit, wherein the physical quantity remains same, it is intact, but you express it in a bigger unit or in a smaller unit. Say it can be from CGS to MKS, or you would convert from MKS to CGS, the other way around. Okay, so for example, you can express 500 newtons in terms of dynes, or you can express 1 dyne in terms of newtons. It is possible. Okay, where Newton is the SI unit of force or the MKS unit of force, and dyne is the CGS version of force. Same way you can express joules also in ergs, or ergs in terms of joules. Joules is the SI unit of energy. Erg, ERG, is nothing but the CGS unit of energy. So like this you can express different physical quantities in terms of their MKS and CGS units by using this relation N1U1 is equal to N2U2. Okay, by using this equality of relations between numerical values and the physical quantities, you can express you can change one physical quantity to another. Provided one physical quantity from one system of unit to another system of unit, provided you know the relations between mass, their length, and their time. So that's all about this. So we'll look at an example now. Yeah. So here you can see they have given you velocity of a train is 720 kilometers per hour. Okay. So they are asking you to express this velocity, which is in kilometers per hour, in terms of kilometers per minute, in terms of meters per second, and in terms of meters per minute. They're asking you different variations. Now, how do you really do this? How do you approach this? Again, you express, use relations N1U1 plus N2U2. You can just equate them and you can find out. So you can fix kilometers per hour. You can see. So you try to express them in terms of the other quantities. So fix one of the units. Let's fix kilometers per hour as the given unit, say the first unit, and the second unit you would wish to change is kilometers per minute. Now here you need to note the point that the unit of length remains intact. What is the changing part between kilometers per hour and kilometers per minute is the time. So the unit of time is changing, wherein the unit of length remains intact. So just change the unit of time appropriately, and then you go for a conversion. Simple. That is what you do. So convert hours to minutes. So you know that 1 hour is equivalent to 60 minutes. So go and express appropriately. You need to multiply with 60 in the denominator, and then you go for a conversion. Simple. So that's how you basically go for a conversion. Second, you would wish to convert kilometers per hour to meters per second. That is also possible. Convert hours to seconds and convert kilometers to meters. 1 kilometer is 1000 meters. 1 hour is equal to, in terms of seconds, 3600 seconds. So express it and then you Go for a simplification, you get the answer. Okay, and last but not the least, meters per minute. Kilometers to meters, you know, just multiply it with 1000, and for hours to minute, you know, you just express in terms of 60. Okay, that's how you do it. Right? So I hope these parts are quite clear to you guys. This is how you do it. And you can see, you can also establish a relationship between Newton and Dyne, also between joules and ergs. Okay, the same way we do it, wherein except for the fact that Newton and Dyne are this MKS and CGS versions of force, joule and erg are the MKS and CGS version for energy. So you would again express them, okay, in terms of from their MKS versions to the CGS version. You try to establish the relationship. That's it. Okay, so you can express, you will get the relation as 1 Newton is equal to 10 power 5 dynes. This is a conversion, and 1 joule is equal to, again in terms of dynes, you can express. Okay, so yeah, you can go and express that is in terms of erg. 1 joule is equal to x ergs. Ergs also you can express. It's not dyne, it is ergs. So in terms of ergs, you can express it. Okay, so like that you can establish in terms of the other units. So 1 joule is equal to 10 power 7 ergs. So like this you can get the relation. Okay, simple. And another type of question which can come is where they express, you know, a new system of unit. They will give you a new system of unit with a condition. Okay, so here you look at this question. There is a new kind of system of unit, system called as the star system, which is defined as 1 kg star is 5 kgs, 1 meter star is equal to 10 meters, and 1 second star is 20 seconds. So they are giving you a new system, which is a star system. The question is, find the value of 1 joule in this new star system. So how do you approach this? Okay, so joule, as we all know, is the unit of energy. So express joule in terms of this star system. So you express them first in terms of the dimension. Go with the dimensional notation. You know that it is m L square T to the power minus 2, and that is what they have written here also. M is nothing but, you know, length. M is nothing but mass. Sorry. So for mass, our normal system is just n, but here in the star system, you know that mass is 5 kg. So in the place of mass, I would represent 5 kg. Okay, and for length, L square in the normal system is length squared, but here in the star system, the length is nothing but, you know, 10 meters. So 10 L square would be 10 meters the whole squared. Same way, T power minus 2. T in the normal system is just 1 second, but in the star system, 1 second is 20 seconds. So you will write 20 whole to the power minus 2. So like this you would express. Then go for a simplification. You would get the answer as 5 upon 5 joules, 5J upon 4. So 1 joule is nothing but 4 by 5 joule star. Okay, in that is in star system. You try to express the relations. So this is how you do it. Okay, this is quite an interesting question where they give you a new system and they ask you the relation with the old system. What is the old system? How can it be expressed in a system that is expressed in the new system? Here it is a star. Okay, a star system which they have given. Okay, is this part clear to you guys?
Yes, sir.
Yes. Okay, this is how it is done. And now moving on to the next part, constructing the relations between physical quantities. This is also an important aspect, how you can try to relate different physical quantities. This also we have done so many questions based on this. So here they have they're asking you to relate the time period of a simple pendulum in terms of the length of the string, okay, which is L, acceleration due to gravity, which is G. Okay, they're asking you what would be the relation for the time period of this simple pendulum. Okay, so whenever a question is asked like this and you wanted to establish the relation between one particular physical quantity with respect to the others, the quantity that they are asking you would keep that on the left hand side, meaning you on the left side you just express it. And all other quantities which they are asking you to build the relation with, you would keep all those quantities on the right hand side. Here they are asking us to relate time period with length and with gravity, acceleration due to gravity, okay, and with mass. So we can write T is proportional to m power A, L power B, G power C, where A, B, and C are the exponential coefficients. Okay, we have to find out the relations. So when you remove the proportionality sign, you guys know you introduce a proportionality constant, say it is K. So T is equal to K times m power A, L power B, G power C. So what is the dimensional formula for T? You know that T represents time. Only T term would be there, wherein mass and length, the powers would remain 0. Okay, so that's the reason it's m power 0, L power 0, T power 1 is equal to, you know that K does not have any dimensions because it is a constant. Constants are dimensionless, so you leave it. And mass, m is representing mass, so mass has just got m, so m to the power A. L is nothing but length, so only L, so L power B. But G is acceleration due to gravity. You know that the unit of acceleration due to gravity is meters per second squared. So dimensional formula would equivalently be represented as LT power minus 2 whole to the power C. Club all the like terms together, mass terms together, length terms and time terms together, you would get m power A, L to the power B plus C, T to the power minus C. Okay, just you need to use the laws of exponents because the bases are same and the powers are different. You can add or subtract the powers. Once you have done that, you can compare on both the sides. Okay, compare the mass terms, compare the terms of length, the powers of length, compare the powers of time, and build a relationship between A, B, and C, and solve them. Get the values of A, B, and C. You get the value of A as 0, B as 1 upon 2, you get C as minus 1 upon 2, and then you go for substitution and simplify. You will get the answer as T is equal to K times under root L upon G. Don't you think this is very similar to the formula of the time period of simple pendulum, which is T is equal to 2 pi under root L by G? Does it make sense? Yes, it does, right? So we have got the relation. So K is 2 pi, okay, by experiments, or the value of K is 2 pi. It's a constant. So finally you get T is equal to 2 pi under root L upon G. So this is how you build the relationship. Okay, this is also one of the applications of dimensions or dimensional analysis. Okay, that's it. This is all about it. So this is how you can do it. Okay, same way for different relations, how you can build the expressions is what they have explained. Okay, I hope this part is also clear. So we'll move on to the next part. So there are different questions. Now these questions and all, I wanted you guys to try. I'll share this so that you guys can also try it and you can get back to me. Okay, yeah. So that's it. So like this, you can find out the dimension. Here they have used a mathematical expression. This is from applications of integrals. They have given you a question here. Again, they're asking you to find out the corresponding dimensions of individual variables which are given in the expression. Okay, so I will again leave this to you guys. You can just go through it. Okay, and you can just mark the questions wherever you have a doubt. I'll come back. So next class we can see that. Okay, now we'll go to the next concept. Okay, all of them are quite similar here. So I will just go to the next new concepts which are there. Okay. Okay, this is the last part of this. So I will close this and next open the next module. The next part. I'll again start sharing, don't worry. And again reshare. Yeah, I'm now sharing the next module. I hope you guys are able to see it. Yeah, is it visible?
Yes, sir.
Yes, okay. This is the next one. Again, the next concepts which are there. So I will introduce the concepts also here. All the concepts are getting covered.
Sir,
Yes, yes.
sir, please send this PDF in WhatsApp group, sir.
Yeah, definitely I will share. Yeah, I will do it. Yeah.
Thank you, sir.
Yes, welcome. So now going on, through this. So we'll see what is this now. One second, I'm just. Yeah, so this is what is being shared, I guess. Yes. So here, we are touching gravitation part. Okay. Now these parts are, areas from where, the probability of questions are usually asked. For example, it is actually, the most wanted areas, from where questions can come. Okay. So those topics are there here. So we'll be touching those concepts, first, and then we will see the questions also based on that. That's the reason, I pulled out these modules today, because as soon as we see a concept, you have an attached numerical, competitive numerical, so that then and there, we can cover the questions also, the typology of questions. Okay, that's the main objective behind doing this modules today. Fine. So here we have Newton's law of gravitation. Now, according to Newton's law of gravitation, you have two objects, or you have two objects with some masses. Say I'm having object A with mass m1, object B with mass m2, and they are separated by a distance of r in space. Okay. Then according to Newton's law of gravitation, the gravitational force of attraction or repulsion between these two objects would be directly proportional to the masses of both the objects and inversely proportional to the square of the distance between them. Okay, this is what the law says. So you can write F is proportional to m1 times m2, and F is inversely proportional means, it's 1 upon, so it's 1 upon r square. You combine both, you get F is proportional to m1 m2 upon r square. Okay, now if you want to remove the proportionality sign, and I know you guys would introduce a proportionality constant, that constant is called as universal gravitational constant, which is represented using the letter G, capital G. As you can see, the value of capital G is experimentally found out to be 6.67 times 10 raised to minus 11. Please note this value can be used, universally, it is true. Means it is used for any particular two objects with finite masses separated by a distance in space, meaning any planet also it is valid. Okay, in the whole universe, wherever you try to find out the force existing between two particles of known mass, you just apply this formula and you find out. Provided you know their masses and you know their distance of separation, you can find out what is the force operating between them. Okay, so that is the main idea behind this theory. So with that, we are moving on. So here you can see. Okay, so I'll just go to the questions. Okay, now here is a question. Now basic formula we have seen. Now we look at the question for this. Okay, the question goes like this: three masses each equal to m are placed at three corners of a square of side A. Now you have three masses which are equal to m, and they are placed at three corners of a square of side A. Calculate the force of attraction on mass m placed at the fourth corner. Meaning, you have one mass at the fourth corner. They are asking you what is the force of attraction with respect to that mass which is placed at the fourth corner. Okay. Now you need to understand that the fourth mass is influenced by three other masses, two being at two corners and one being at the diagonal end. All right. So you will try to find out what is the force operating between them. Very simple. You just go and apply what is the Newton's laws. According to Newton's law, you know that F is equal to G times m1 m2 upon r square. Here masses are same. You can write it as G m square upon a square, isn't it? That is one. And with respect to the mass that is on the opposite diagonal, you know that length of the square of the diagonal. This is a square, right? Because all sides are equal. What would be the length of the diagonal? It is root 2 times the side of the square, right? Root 2a or root 2l. If the side of the square is going to be a or l, so root 2a, that's the reason they have put root 2a, the whole square, and you just need to add them. So it's 2f plus f dash, where f dash is nothing but the force due to the mass on the diagonal end, and 2f is nothing but the forces due to the masses on the sides of the square. So the combined force operating on the fourth particle would be 2f plus f. Now can anybody simplify, take the LCM and tell me the final answer for this? Because in MCQs you have to tick the options which are the simplified version of the answers. Here it is not simplified. Can anybody simplify and tell me the correct answer? Let me just verify if you're able to do it. What is the force? What is the final answer? Take all LCM, do the rationalizing, and then tell me the answer. Just try it. You have a notebook, please do it and tell me, so that we will verify that you are doing the right way. Yeah, you can do it. You can tell me. Yes, what is the final expression that you're getting for F in terms of G, M, and A? Anybody? Yes. Are you guys understanding how to approach this question? Please.
Sir,
yeah.
Sir, F is equal to 2F plus F dash எப்படி சார் வருது?
ஸோ 2F வந்து இந்த ரெண்டு மாசனால வந்தது, இந்த ஒரு மாசம் இந்த ஒரு மாசம், சரியா? அதுதானே F. F is nothing but GM M square by A square தானே. ரெண்டுமே சேம் டிஸ்டன்ஸ்ல இருக்கிறதுனால GM square by A square வந்துச்சு. மூணாவது மாஸ் இன்னொரு மாஸ் பாத்தீங்கன்னா இட் இஸ் அட் த டயகனல் எண்ட். இந்த லென்த் வந்து A கிடையாது, இது வந்து √2A தானே. This length
yes,
is 2, isn't it? That's the reason F dash is the force existing between this fourth mass and the mass which is at the diagonal opposite corner. So combined force will be 2F. 2F, why we are saying 2F? Because there are two masses on the sides of the square and the distances from this fourth mass is same. That is why 2F. Twice the force.
Okay, sir.
So இப்போ நான் என்ன கேட்டேன், நான் வந்து I am asking you guys to simplify this and tell me the final expression. So what will be the answer? 2F means what? 2 times G M into M is M square by A square plus F dash is how much? Again G M square upon √2A whole square. When the simplify பண்ணீங்கன்னா you will get 2A square, isn't it? Can you go for a common? Can you take a common out? What are the terms which are common here? G is common.
GM square A square, sir.
Yeah, GM square upon A square is common. So you will get 2 plus 1 by 2. If simplify பண்ணீங்க அப்படினா LCM எல்லாம் எடுத்த பிற்பாடு you will get
4/2, sir.
5 or 4. 5 GM square.
5/2, sir.
Yeah, 5 GM square by 2A square வருதா?
2A square.
Yes, this is what I was asking. உங்களுக்கு வந்து MCQs ல in the exam they will give you options like this: 5 GM square by 2A square, 4 GM square by A square. And the mari they will give you different varieties. You will have to select the correct option. Is it clear?
Yes, sir.
Yeah, this is how you will solve it. Okay. Same way you have another model also. You can see here they have given you another question. They're asking you what are the forces, which is the force experienced, or what is the question here? Okay, question itself is a diagram. Okay, they are asking you what is tan theta. You are having two objects, okay, which are hung from a string. Or a string கொடுத்திருக்காங்க. The length of the string is L. The distance of separation between those two strings, okay, is R. Okay. Now the question is, what is the angle theta is the question. They are asking you to relate angle theta. So here, whenever you have objects which are suspended, you know that there is going to be a tension that is going to act. Yeah. whenever you have an object that is suspended from the wall or from the ceiling, on the top, from the roof or from the ceiling. Now, what are two forces which are going to act? One is going to be the weight component which acts, and one more is going to be tension.
Sir, we want to divide equation 1 by 2, sir.
Yeah.
We get tan theta equal to F by mg, sir.
Correct.
Force is equal to Newton's the law of gravitation, sir.
Yes.
G m1 m2 by r square.
Correct.
And mg is taken as m1 into g. M1 and m1 cancel, sir.
Yes.
We get gm2 by r dash square into g, sir.
Yes, that's it. That's how you do it. Now here, our point of interest is only this. I'll just square it in blue. This part. When those two objects are pulled by some angle theta, then what is the force existing between them is what the question, and you find out the angle theta for that. So in that case, you will find it like this using this relation. Okay, quite simple. If you understand the logic, it is very easy. So that's how you approach that question. Okay. Next question. Two particles, each of mass m, goes around in a circular motion and their mutual gravitational attraction. Find the value of speed with which the particle is doing a circular motion. They're asking you what is the speed. Now, whenever you have an object that is moving in a circular path from a fixed point in the center, and the radius is remaining unchanged.
Centripetal force, sir.
Correct. The force operating here is centripetal force. Centripetal force, you guys know, it is an inward seeking.
Yes, sir. F is equal to mv square by r, sir.
Yes. Okay. You equate that force should be balanced, right, by the gravitational force. So that is the reason you will substitute. You will equate centripetal force with the gravitational force. So equate them, and then you can find out what is the velocity. Okay. That is the approach. Fine. Simple.
Yes,
so,
sir.
Two particles. Did you understand how this 2r came? Because the distance total diametrical length will be 2r, twice the radius, no, diameter. That is why you will substitute 2r. Okay, simple. So you will get v is equal to 1 by 2 times under root gm upon r. Simple. And then you have relation for gravitational field. So what is gravitational field? It is the region surrounding the mass, where if you have any other mass, it will experience some gravitational force. Then you say that particular region where it is experiencing gravitational force, you call that region as gravitational field. Okay. So very similar to magnetic field. Now, what do you mean by magnetic field? The region surrounding the magnet where its influence is felt. That is magnetic field. Same way, gravitational field is the region surrounding where the effect of gravity is felt for a particular object with any mass. Then you call that as gravitational field. Simple. So here they are just generalizing. You should know this relation, this basic relations, that small g is equal to g times m upon r square. Okay. Once you know that relation, then you try to find out what is the expression for gravitational field of any particular particle. Okay. So this involves integration. So for that, you should know how this expression came in the first place. So any idea how you know this expression came? Anybody? Can you just try?
Sir.
Yeah.
Sir, the formula is g is equals to gm by r square, sir. There is a small change in g and mass, sir.
Okay.
There is a length dm to dg. There is a small length, sir. Root of x square plus r square, sir. We substitute in equation 1. The root and the square will cancel off, sir. We get dg equal to gdm by x square plus r square, sir.
Okay. Actually, that is not the explanation part. You're trying to just justify how it came, but it is coming. It's an application of your Newton's law of gravitation. So we apply Newton's law of gravitation with respect to an object which is at a height on the earth. Okay. So that is how that came. It is very interesting if you know how it really came. So you take Earth as a frame of reference. I'm just drawing a big hemisphere here. Imagine this is the Earth. Okay. And the Earth has got a center. Yes, of course. So say this is the center of the Earth. And then what would be this length called from the surface of the Earth to the center of the Earth? It is nothing but radius of the Earth. Yes. This is the radius. Now imagine I am having a particle which is placed at a certain height from the Earth. Okay. So I will call this corresponding height as, say, this I will call it as h. Okay, this height I will call it as h, and the object has got some mass m. M is the mass of the object. Yes.
Sir, I had a doubt, sir. Sir,
Yeah.
we want to resolve two components, sir, horizontal and vertical component.
Yeah. You'll have to find out in terms of, that is for the next part you're asking, right?
Yes, sir.
Yeah. Next part I'll come to that later. First, you try to understand how this first relation came. Okay, I do appreciate your curiosity in understanding concepts, but first for that we need to know how this particular expression came in the first place. Okay, that is what I'm explaining.
Okay,
so,
sir.
Yeah. So first thing that you should know, whenever you have an object with some mass m, which is placed at distance of height, from the surface of the earth, now we try to find out the gravitational force existing between these two particles. Now when I talk about two objects here, one is a celestial body, which is the earth, the other is a small object with having a mass of m. Do you agree? These are the two particles that we are talking about, a two system. Okay, now when you apply the Newton's law of gravitation, F is equal to g times m1 m2 upon r square. This is what the formula tells us, isn't it? So
yes, sir.
Yeah, I'm going to apply this. So it is g times, now what is m1 here? M1 we will take it as the mass of the object that we are talking about, which is nothing but m. Now what is m2? M2 is a big mass, which is the earth. So me, I will write it as me. G times m times me upon, now r square. What is this r? R is nothing but the distance between the center of mass of both the objects. So when you take the total distance between both the objects, don't you think this has to be re plus h? Yes or no? Isn't it? Between both.
Yes, sir.
So it is radius plus the height.
Radius of the earth plus the height, sir.
Yes, re plus h the whole square. Okay. Now, according to the Newton's law, whenever you are an object which is freely falling, right? Now, you know that what is the corresponding value for force that we can express here? Whenever you have an object that is freely falling, what is the force? Don't you think the force that it is going to experience will be purely due to the gravity, right? When an object is freely falling. So, in the place of F, can I substitute m into g? The weight component would act vertically downwards, correct? So I would substitute m into g. Now both the sides, what is getting cancelled off? You can see the terms. You have the mass term which is getting cancelled off. Okay, so mass term goes away. So we can establish g is equal to capital G times me upon, now re plus h. Can I go for an approximation?
Sir, h is very small than re, sir.
Yes. So it will be equal to re itself, because comparison to the radius of the earth, the height of the object is negligible. You can neglect the height. So it becomes re whole square. So you would simply get g is equal to capital G times m upon r square. That is how this relation came in the first place. Okay. Now once you understand this logic, the other steps would be easier for you. So this is how you try to relate, the expressions one by one. So for a freely falling object, you apply Newton's law of gravitation, try to simplify and get the expression. Then at a distance, at a point P, now you try to find out what is the corresponding value of g that an object is going to experience when it is at an axis. When it is at a particular distance from the center of axis, they have taken it as x and the angle is theta. Okay, and then you try to, you can see by Pythagoras theorem, you can express the hypotenuse as under root of x square plus r square. Okay, and then you go and substitute in the relation, because you know that g is equal to gm upon r square. For a small particular by an angle, if you're going to tilt, then what is dg? You can express dg as g times dm, when you take a small particular mass and then you try to express it. So here you go for an integration. Why am I integrating? Because you take a small part and you add all those parts, you will get along the entire length. That's why you go for an integration. Integration is nothing but adding. You take a small strip and you add all the strips, so you would get the entire, for the entire circle you will get. That's the reason you go for an integration here. Okay, so you integrate it and you express it. So they have done here integration by substitution method. So you can go for integration and then you try to find out the relation. So integration of, so here you have g times dm upon x square plus r square. Now how did we arrive at this corresponding step? Anybody? Integration of dg is nothing but g. Okay, then you again go for integration. So here constants can be removed out of the integral sign. Okay, so g can be taken out of the integral sign. But what about this x square plus r square? Okay, so you can see that you can express them in terms of the angle theta. Yes, you can express in terms of theta. What is cos theta here? You know that cos theta can be expressed as the ratio of the adjacent and hypotenuse, right? That's what they've done here.
Adjacent by hypotenuse side, sir.
Right. So that's what they've done. So adjacent side upon hypotenuse, that is what is cos.
X by root of x square plus r square, sir.
Correct, that's what they expressed. Then they go for a simplification. Okay, now whenever you have the, you can see here x square plus r square times x square plus r square whole to the power 1 by 2. Now the bases are same but the powers are different, so you can add the power, powers. 1 by 2 plus 1 would give you 3 by 2. That is why
3 by 2, sir.
Okay, so you will get gx times gx upon x square plus r square whole to the power 3 by 2 into m. So that's how you get the gravity, the value of acceleration due to gravity of a particle acting at a point P with respect to a small point dm at an angle, making an angle of theta. So this is how you can bring in the relations. Okay, so same way they are expressing for a hollow sphere, for a solid sphere. Okay, I will share this, please go through this. Okay, there are all the concepts are clearly given here. I want you guys to just brush up. It's quite understandable, very down to earth. They have given you step by step approach. They have not skipped any steps, so it's quite easy and understandable. I want you guys to go through this. We have also I'll also explain it again if you want, but first I want you guys to go through, and then we can look at different types of questions. Once this part is clear, all the formulas are clear to you, then we can directly start solving all the different types of questions which can come from the competitive point of view. Because when you do directly, when you do the solve the questions, things might go above the head, because certain questions are high level questions, or we can say advanced level questions. So that's the reason. So once you do all this, we look at all the concepts here and look at all the formulas which are given. Maintain a separate notebook, write down all the relations, write down the formulas chapter wise if you can maintain and if you can remember. So your 80% of your job is done. Rest 20% is practice. You can you just need to write them and again check all the formulas whether you've written them right. Then you can start. You're good to start practicing all the numericals. Okay, so what I will do, I will start sharing all this these materials that I'm having today. I have discussed 2 modules, so 2 modules I will post it in WhatsApp. I want you guys to go through both the modules. Okay, once you can go through them, then we can start doing questions based on the modules that you've gone through. All right, so I think we'll wind up here. Okay, so I hope today's session was
Thank
useful.
you, sir.
Yeah, welcome children, take care. So see you in the next class.
Thank you, sir.
Yeah, welcome.